Alright everyone, so in this section, we are going to explore an important data structure in programming called a queue. You can think of a queue as being similar to the line or queue you see outside the cinema hall. In this queue, the first person who enters is also the first one to get the ticket. Now, the queue operates on the principle of first in, first out. This means that the item that is added to the queue first will be the one that comes out first when we start removing elements from it. Just like how the first person in the cinema ticket queue gets the ticket first. So, with queues, we always maintain the order of items as they are added, and when we start processing them, we follow the same order in which they were added. The FIFO rule, which is first in first out rule, makes queues really handy in various programming scenarios. Let's dive deeper into how queues work and what makes them so useful. Alright, let's take a closer look at the image provided. As you can see, we have a queue with the letters A and B in that order. Now, since A was added to the queue before B, it will also be the first one to be removed from the queue, following the first in first out FIFO rule. In programming, we have specific terms for these actions. When we add an item to the queue, we call it enqueue, and when we remove an item from the queue, we call it dequeue. Now, the great thing about queues is that we can implement them in various programming languages like C, C++, Java, Python, or C#. The fundamental specifications of queues remain pretty much the same regardless of the language we use. So, this makes them versatile and widely applicable in different programming scenarios. So, let's explore more about how we can use queues and the various operations we can perform on them. A queue allows us to perform several operations to manage our data effectively. The first operation we will look at is called enqueue. When we enqueue an element, it means we are adding it to the end of the queue. Think of it like standing in a line and you join the back of the line. At next, we have the dequeue operation. When we dequeue an element, we are removing it from the front of the queue. Picture yourself at the front of the line and it's your turn to move forward and exit the queue. To make our lives easier, we can check if the queue is empty or full using the isEmpty and isFull operations respectively. It's like looking at the queue to see if there are people waiting or if it's already at maximum capacity. At last, we have the peek operation. This operation allows us to take a sneak peek at the front of the queue without actually removing the element. It's like quickly checking who is at the front of the line without asking them to step out. With these operations at our disposal, we can efficiently manage data using a queue in various programming languages, whether it's C, C++, C#, Java, Python, or Golang. The basic functionality of a queue remains quite similar. So, let's continue exploring more about queues and how they can be used to solve different kinds of problems. Alright, let's dive deeper into how the queue's operations work. We use two special pointers in a queue called front and rear. These pointers helps us to keep track of the first and last elements of the queue. When we start with an empty queue, both front and rear are set to -1. It's like saying we haven't added any elements to the queue yet. As we enqueue elements into the queue, rear gets updated to the point to the new element we just added to the end. Think of rear as a moving pointer that always points to the last element. And as we dequeue elements from the queue, front gets updated to the point to the next element in the line. Front acts like a moving pointer that always points to the first element. So, Using these front and rear pointers, we can efficiently manage the elements in our queue. As we add new elements, rear moves forward, and as we remove elements, front moves forward. This way, we can maintain the order in which elements were added following the FIFO rule. Alright, let's now understand how the enqueue operation works in a queue. Before we add an element to the queue, we need to check if the queue is already full. We don't want to add more elements than the queue can handle. Now, when we add the first element to the queue, we set the value of front to 0. This is because we have just one element and it's both the first and last element in the queue, right? So now next, we increase the rear index by 1. It's like saying, hey, we have a new element and it's going to be at the end of the queue. So finally, we add the new element to the position pointed by rear. So now we have successfully added an element to the end of the queue and our queue has grown by one element. So that's how the enqueue operation works. Now let's learn about the dequeue operation in a queue. Before we remove an element from the queue, we need to check if the queue is empty, right? We don't want to remove elements when there is nothing in the queue. That's impossible. So if the queue is not empty, we proceed with the removal process. The first element in the queue is the one pointed by front pointer. So we return the value that front is pointing to, and that's the element we are removing from the queue. So after removing the element, we increase the front index by 1. It's like saying the first element is gone, so now the next element will be the first element. So now there's one special case we need to handle. If the last element is removed from the queue, we need to reset the values of both front and rear to -1. So this is because if both pointers are set to -1, it indicates that the queue is empty. And there you have it. That's how the dequeue operation works in a queue. It allows us to remove elements from the front of the queue, just like how people in a line comes forward and get their turn. Now, let's discuss some limitations of the standard queue. As you can observe in the image below, after a series of enqueue and dequeue operations, the size of the queue has reduced and we can only add elements at index 0 when the queue is reset, when all the elements have been dequeued. However, there's a way to make better use of the available space. When the rear reaches the last index of the queue, instead of leaving those empty spaces unused, we can utilize them to store additional elements. This modification is known as the circular queue. By employing a circular queue, we can optimize the use of space, making it more efficient and practical for certain scenarios. This is a valuable enhancement to the standard queue and it allows us to manage the data more effectively in various applications. Now, let's discuss the complexities analysis of the enqueue and dequeue operations in a queue that uses an array. The complexity of these enqueue operations is constant time, denoted as big O of 1. It means that the time taken to enqueue an element into the queue doesn't depend on the number of elements already present in that queue. So, adding an element is a fast and efficient operation, regardless of the queue's size. Similarly, the complexity of the dequeue operation is also constant time, represented as big O of 1. This means that removing an element from the front of the queue is a quick process, regardless of the queue's size. Overall, using an array to implement a queue ensures that both enqueue and dequeue operations are efficient and have constant time complexities, making it a reliable data structure for managing data in various programming scenarios. Let's explore some of the real-world applications where queues come in handy. CPU scheduling and disk scheduling. In operating systems, queues are used to manage tasks for the central processing unit and to handle disk operations efficiently. Tasks are placed in a queue and scheduled for execution based on priority or other algorithms. Data transfer and synchronization. When data is transferred asynchronously between two processes or devices, queues are used for synchronization. For instance, input-output buffers, pipes, and file input-output often employ queues to manage the flow of data. Interrupt handling in real-time systems. In real-time systems, interrupts need to be managed promptly and efficiently. Queues are used to prioritize and handle interrupts as they occur, ensuring timely responses. Call center phone systems. Call centers use queues to manage income calls and in organized manner. When people call the center, they are placed in a queue and calls are answered in the order they were received, following the first in first out principle. By understanding the various applications of queues, we can appreciate their versatility and importance in solving real world problems efficiently. Queues enable us to organize and manage data effectively, making them a valuable tool in computer science and various industries.